Today we're taking what we've learned before in 6.1 and we are kind of expanding on that knowledge. Today we are talking about comparing percents to fractions and decimals. So this IXL is what I'm going to be using to teach you, and then you're going to actually complete this IXL as well. So we're talking about which one makes the statement true, which sign makes the statement true. So as you should remember, this is a greater than sign, this is a less than sign, and this is an equal to sign. So if the number on the left is bigger than the number on the right, you're going to use this one. If it's smaller on the left and bigger on the right, you're going to use this one. And if they're equal to each other, you're going to use that one. So in order to complete these problems, you have to make sure your numbers are speaking the same language. Right now, this one's speaking percent language, and this one's speaking fraction language. My personal preference is to get everything into decimal form, because that's kind of sort of the middle conversion. If you look over at this table, this is kind of sort of our process of converting between the different languages. So if I'm given a percent, I have to change it to a decimal before I can change it into a fraction. And if I have a fraction, I change it to a decimal before I turn it into a percent. And so like I said before, decimal is kind of that middle ground area. If you wanted to go from percent all the way to fraction, in order to compare those two numbers, you're more than welcome to. My personal preference, though, is just getting the decimal of each. And so that's what I'm going to be doing to solve these problems. Again, do it however you want. There's a million different ways to do math. So if I look over here, if I wanted this number to be into decimal form, I know I have 75%. To get that into the decimal form, I'm going to divide by 100, which means I'm moving the decimal to the left, or to the right, sorry, by 2. Or sorry, oh my gosh, I'm messing up. Backtrack. I'm going to be moving it to the left, like I was trying to say originally, by 2, because the decimal is currently right here. And so that takes the decimal. So currently it's at 75, then it's 7.5, and then it's 0.75. And so this number in decimal form is going to be 0.75. When I'm doing this one over here, I can either take 3 divided by 5. I could take this 5 and make it into 100 and then change the top part to be 100, and then I would be able to easily convert that into a decimal. Or I know that 1/5 is 0.2. So since I have 3, I know for sure that this is going to be 0.6. So just to kind of prove myself, I'm going to change that denominator into 100. And so it's currently a 5. In order to get it up to 100, I'm going to have to multiply by 20. 5 times 20 gives me that 100 that I need on the bottom. Whatever I do to the bottom, got to do it to the top. 3 times 20 is 60. And 60 divided by 100 gives me that 0.6. Technically, I could have a 0 there if I really wanted to, which makes it a little bit easier to compare these two numbers. I've got 60 cents and I've got 75 cents. I know that 75 cents is going to be more than 60 cents. So we're going to be using that sign there and submit our work. They gave us another percent and fraction. This one's super easy. 90% is going to be 0.990. And then a half, I know, is 50 cents. So it's going to be 0.50. So now that I've converted those into decimals, the same language, I can communicate with each other. So 90 is bigger than 50. I'd rather have 90 cents than 50 cents. Okay, so this time they gave us a percent and a whole number. I know this percent is going to be a decimal, and that decimal is going to be 0.57. And even though I don't see a decimal point, this is in decimal form already because it's 19. It's not a percentage, it's not a fraction, which means it's in our decimal form. So technically we can throw in a 19.0. So we're comparing $19 to 57 cents. I think we can all agree we would rather have $19.57. And then it's going to keep going on like that. We're going to jump a level. So once you get up to 60%, it just starts getting a little bit harder because there's more numbers. But as long as you just follow our rules and treat it the exact same way, you're going to be able to figure it out. This right here, I know is going to be in decimal form. So this is in the correct form that we want it in. This right here, I see a percentage, so it's going to be in percent form. It's only going to be in one of those three forms. So figure out what form it is and what form it needs to be. So if I take this percentage, 90.39, and I wanted to make this percentage into a decimal, I'm moving that decimal 1, 2 to the left. And so that's going to give me 0.9039, which, hey, would you look at that, is the exact same as the other one. So that means that this is an equal statement. So then we're comparing two percentages. That's easy. They're in the same language already. So for this situation, I personally wouldn't change it into decimal because they're already speaking the same language to each other. We know that 18% is greater than 16%. So sometimes you will have that as well. Once you make it up to 70%, you're done. You can stop. However, if you make it up to 80%, I'll give you 1 bonus point. If you make it up to this 90%, I'll give you 2 bonus points. And if you can make it all the way up to the 100% of your SMART score, I will give you 3 bonus points. If you have any questions, let me know.